All of us are engaged in design activities, but many people are not aware that there is a process for design, a place to start, and steps to follow. We call it a systems approach. Hello, my name is Peter Jackson, and I am a professor at Cornell University. I am also director of the Systems Engineering program at Cornell. I've had the good fortune to work with many professionals who excel at design and engineering. In addition, I have created a few products and services of my own in the software area. I've concluded that the lessons of design are quite simple, and that we should make these as broadly available as possible. So, no matter where you are in your education or career, you can benefit by spending some time with us. So what sort of design activities are you interested in? Perhaps you'd like to create an internet business. Or, like one of my students, you'd like an invention that would open your front door when your arms are full of babies and grocery bags. Or perhaps you'd like an invention that would detect a deer running in front of your car. But think more broadly now. How about a service that delivers vaccines to children in remote parts of the world? So you see, it's only our imaginations that limit us. Getting design right, a systems approach, is about the design process. It is about taking an idea for a product or service and developing the idea to the point where you can turn it over to teams of engineers and technologists who will build it for you. We do not expect that you will do the engineering yourself, but you will have to be very clear about what you want the product or service to do. You will want to get the design right. In addition, you will want to make sure that whatever the teams of engineers and technologists deliver back to you works and fulfills the design criteria that you establish. That's what this course is about. We also talk about what goes wrong in designing systems and provide lots of examples. Ships that get blown over and sink, missiles that miss their targets, exercise equipment that causes varicose veins, computers that are too expensive to build, ships that don't have enough lifeboats, spacecraft that fly millions of miles off course, telescopes that can't see straight, and production processes so complicated that nothing gets built. In each case, we trace the problem back to what step in the design process was missed or done badly. We can learn a lot from great mistakes in the past. This is a practical course. To keep it simple, we will focus on a simple product, a toy catapult for my grandchildren. I have two toy catapults here to illustrate the range of design possibilities. This one is by Schleich. It is a replica of a toy catapult. It's made of painted vinyl and looks very realistic and attractive. This other one by Pathfinder is more basic in appearance, and it operates on a spring principle using twisted rope. Let's test out the performance of these two catapults. I'll take the Pathfinder. I have an eraser which I will load into it. We cock it and fire. So you see the performance is quite good on that one. Let's try it again with the Schleich catapult. Again, this is a trebuchet principle, and we will load this with the eraser and release it, and we find it is quite disappointing. So you can see that the design space is quite large for these catapults. There is lots we need to think through as we develop our ideas. We will use a systems approach to do that. By a systems approach, I simply mean that we will use a process by which we systematically discover what we need to think about in the design. Who is the customer? What does the customer value? What are different ways we could deliver that value? How will we evaluate our product? And so on. We will study our design from many different viewpoints. You will also learn the language of systems and become comfortable with describing products in terms of their subsystems, relationships, behaviors, and interfaces. This course is really an introduction to systems engineering, but don't let the word engineering frighten you away. There is very little in the way of mathematics or physics that you will need to succeed in this course. This is a hands-on course. You will apply the concepts of this course to a design idea. It can be your own idea, or you can work with one of the design ideas that we give you. For example, how would you like to work on a bathroom cleaning robot? Or a wristband that monitors a patient's health so they can leave the hospital and live at home? Or how about an internet-based meal delivery system? Whatever the idea, you will take it to the first level of design, ready to turn over to the engineers and technologists. This is a unique course. We know of no other like it at any university. By bringing together Cornell's strength as a research institution and our extensive contacts with industry, we have brought together the best ideas in design and systems engineering and distilled the essence of what is truly essential for a systems approach. This is a new kind of course. It is college level, but you do not need to come to the Cornell campus to take it. It is available through distance learning, through Cornell's Office of Continuing Education and summer sessions. If you are a community college student, this course will give you a chance to explore a career possibility and to test the waters at an Ivy League institution like Cornell. If you are considering transferring to Cornell, this will give you a chance to see what makes Cornell unique. So give this course some thought. No matter what your background, you will benefit from taking this course and have fun doing it. We hope you'll join us.